there, my name's Gabby.
Hi, my name is Natalia, and we'll be your safari guides today. Today we'll be exploring the different methods of counting. Let me introduce you to our passengers.
Hi, I'm Alex.
Hi, I'm Natalie, and we're so excited to learn today.
Let's look around and see what we discover. Come here, mates. Look what I found.
You have found the wild species of permutation.
A permutation is a number of ways of selecting and arranging R objects among n total objects. Here, order does matter.
What do you mean order matters? I don't get it. Can you explain?
Yes. This is a formula for permutation. Here, order does matter. It is represented by the equation n factorial over n minus r factorial. It can also be represented by n, p, which stands for permutation, r. N represents the total number of objects in the set. R is the number of objects we pick from the set. There are two types of permutation: permutation with repetition and permutation without repetition. Let's see an example. So here we're doing a problem with repetition. And the example is, in how many ways can the word kangaroo be arranged? We use the formula n factorial over number of times the letter A is repeated, factorial, times the number of times the letter O is repeated, factorial. The total number of letters in the word kangaroo is 8. The number of times A was repeated is 2, 1, 2. The number of times O was repeated is 2, 1, 2. Therefore, we use the formula 8 factorial over 2 factorial times 2 factorial. And we end with 10,080. There are 10,080 ways that the word kangaroo can be arranged.
Now, an example of permutation without repetition is the following. Given that there are 6 people waiting to get on a Jeep, Oliver, Sydney, Liam, Henry, James, and Jaden, suppose there are only 3 spots available for the Jeep ride and they have to sit in alphabetical order. How many different seating arrangements can be made? The formula that we would use is n factorial over n minus r factorial. In this case, n equals 6 because there are a total of 6 people waiting to get on a Jeep, and r equals 3 because there are only 3 available seats. So we use 6 factorial over 6 minus 3 factorial, and it gives us a total of 120 possible seating arrangements.
Now let's look for other counting methods. Come along and join us.
Look over here.
It's a rare combination species.
Yes, you are correct. The formula for a combination is n factorial over n minus r factorial, which can also be represented by n, c, r. N equals total number of objects in a set, and r equals the number of objects we pick from the set. Here, the order does not matter. For example, in our Safari Guest Center, there are meat pies being given away. In the lucky draw that 20 people have signed up for, only 12 will be chosen. How many different ways can 12 winners be chosen? We use the formula n factorial over n minus r factorial times r factorial. N equals 20, since there are 20 people that have signed up for the draw, and only 12 people can be chosen, so r equals 12. Therefore, we use the formula 20 factorial over 20 minus 12 factorial times 12 factorial, and we get the answer 125,970. There are 125,970 different ways that 12 winners can be chosen.
Here's another example of combinations. Suppose you're at a restaurant and you have to choose 3 desserts out of a menu of 10. How many different ways can the desserts be chosen? The formula we would use is n factorial over n minus r factorial times r factorial. N is equal to 10 because there are a total of 10 desserts in the menu, and r is equal to 3 because we can only choose 3 out of the 10 desserts. We would do 10 factorial over 10 minus 3 factorial times 3 factorial, and we get a total of 120 different ways the desserts can be chosen.
Thank you for joining us on our tour. Tune in next time, mates.